This video will look at how to use regression or technology to find the equation that best fits your data points. Remember, so here's my Hershey Kiss, and I've already put in my data points. Remember, what we're going to do is something similar to the very beginning of the year when we did the selfie, and I asked you to create a picture of yourself, right, by kind of tracing or creating equations to come up with features of your face. Well, now I want you to use, you don't need to come up with the equation by yourself. You can actually use technology to come up with that equation. So here again is my Hershey Kiss and data points. I'm going to go ahead and turn the picture of the kiss off. So I want an equation that best fits these data points. So what do you think might be the best type of equation? Well, if you thought of a sine, right, and we at the beginning of the year came up with talking about the amplitude and the period and the shift. Well, using technology, we can ask it to fit a sinusoidal equation. So what you want to come in here is notice that and I actually want to create an equation right here. So hold on one second. Let me bring this equation up. And I'm going to delete this equation. Okay, so our data points are labeled x1 and y1, right? If you created a new table, they would be called x2 and y2 and so forth. So the equation we want is a y equals sine of x equation, but we want it to fit these specific points. So instead of just typing in y, I'm going to type in y1. y1. The minute I make the 1 in there, it will become a subscript. Now, instead of putting an equal sign, what denotes doing regression is the squiggly sign that's right next to the number 1, to the left of the number 1. All right, so that's telling the desmos or the computer to do a regression. Now, we want to put our parameters in there. So A sine, I'm going to do parentheses B, right? That's my period parameter, parentheses. I don't want to just put X in there because remember our data is X1, Y1, so I'm going to put X1, and notice it's actually already started to create an equation that's just based on the parameters A and B. So I'm going to also add a C in there, and then even add a plus D at the end. And that actually is not a bad fit. So there's a nice sine equation that fits our data. You now can, if you want to restrict the domain, right, rewrite that equation. So notice here, if you look in this box here, right down here, your parameters, your A, your B, your C, and your D are all written right here, and that's what technology is saying is the best fit for this line. R squared is something called the coefficient of determination, and the closer it is to 1, the better the fit is, so 0.998 is actually excellent. A residual, don't worry about it, but notice that E is what they're using for the variable, so don't ever use an E in your equation, and I'll talk about that in a second. So I actually rewrote the equation down here, right? This didn't automatically happen. I rewrote it, and then at the end, and if you can remember this from the beginning of the year, we can restrict the domain. So I'm going to add in here a squiggly bracket, and let's say we want it to start at 0, less than x, less than, and I want it to go to about 21. And now I'm going to turn off the regression, but I'm going to turn on this equation, and there is my curve to best fit that equation. And I could even use desmos. Let me add another expression right below here to find that volume for us. Remember, the formula is pi, and then I can do my int for integral, and I want to go from 0 to 21. I can copy. Again, I don't want to copy the restriction, just copy the function. And I'm going to put in here a parentheses. There's my function. I want to actually, what did I just do? I deleted it. I want to come down here and square it, because remember this is using disks. And then if I add a dx at the end, voila, it comes up with a volume right away. Remember, in your little mini poster, you want to have the expression for the volume of the solid as well. So there is using regression and a sinusoidal equation. But if you wanted a different type of equation, you could just come in here and notice right here, I have already done a quartic. I put in y1 and then a x1 to the 4, b x1, right? So again, every time you use an x, you want to use a 1 because it's denoting that it's taking it from the table with x1 and y1s in it. And I've just written a quartic. I did not use e here because, again, remember I talked about they use e as one of their variables here, so that's the only one you don't want to use. And if I go ahead and turn this on, right, there is the quartic equation. You know, how does that fit any better? And that's up to you to decide. So there are two different, I used a quartic and I used a sinusoidal. You could come up with any equation in here whatsoever. This quartic equation, notice here are the parameters here, right? In front of the x to the 4th is negative 0.0001, right? You can see I rewrote it here. It's got a nice r squared value, 0.999, although the equation is a little bit more difficult to work with than our sinusoidal equation up here. But I called this g of x and I found the volume of that. And it's about 3,574 compared to 35, so they're pretty close together, the volumes on there. But you could add in any sort of function in here. Here I was trying to fit in a natural log, not that I thought it would work. And actually, if you've noticed that weird blue line, that was my attempt to come up with a natural log, and that didn't work in here. But let's say we wanted to add a cubic real quick. I could put in a x1 to the 3rd plus b x1. Again, remember you got to put that subscript in there every single time and make that squared. And then how about plus c, right? So here is my quartic equation. And they're all actually hit pretty well. And again, here are my parameters that I want to use for that. So it's up for you to decide which type of function you think best fits your equation. I can even add something that I know is not going to fit, but just show you if I think a square root. So maybe I want to come in here and do a square root x1 minus b plus c, and again, I know that's really not going to fit, but there's how I can easily put in if I think a square root is something that might fit, I might want to use that as well. And that's how you use Desmos to do regression or technology to help you find the equation that best fits a set of data points.